So they say there's no I in team, but there's an I in BIM, and that's really what I'm going to talk about is information. The importance of information, it's not just about getting that information, it's the quality of that information. So when we look at the data that we need to decarbonize, to meet our climate objectives, the quality of that is important. So thanks for the intro, Matthew. My name is Archie O'Donnell, and my background is in sustainability, architectural technology, and recently in cost management. And what I'm trying to do is put them all together and see where they intersect. And where they intersect, really, it all comes down to good information management practices and being able to communicate those results to the stakeholders and to the clients. Now, our focus in KOSMOS, as Ross would have outlined in his talk earlier, is on value-driven sustainability management. And really what that's about is the people. It's about a collaborative approach. We're not going anywhere unless we use a shared approach. We've got to do this together with mutual goals. And it's about integrating this. So integrating it across platforms, but connecting the dots, making sure that the people who have influence over the important stuff like cost can also start to contribute at an early stage to the sustainability outcomes. And make sure that decision making is informed by the numbers, by the metrics. And it's all about not just doing this once, but about tracking this and following it up. So it's cost control and reporting. So it's a whole life cycle approach to this. And life cycle will be important, and I'll get into that. So our discussion today really on that topic, we're going to first talk about, the stuff that Zero is doing, this whole idea that in order to talk about sustainability and carbon, you need to understand it and have the language about it. So the legibility, having a literacy around carbon is important. We'll talk about the challenges. As we all know here, getting data, getting reports together, getting buy-in, it's difficult, and we'll talk about those challenges. We'll also look at standardization and data, and that's something that's familiar to BIM people, the ISO standards, the guidelines, and we'll look at where the synergies are there. And we'll also look at what's best practice. Are there any learnings we can take from other jurisdictions who've done this before? So what's driving this? And really, we're on a road to 2050, but 2050 is never, never. Really, we're looking at 2030. Where have we got to be in 2030? We're not starting in 2030, but we should have our stuff together in 2030. So the drivers, we've got twin drivers. One is we're trying to rapidly decarbonize our processes, our materials, and our energy systems. And we started that through renewables, through environmental declarations of products, and generally just trying to be better citizens that have a less impact on water, energy, carbon, materials. But at the same time, we have a housing crisis, and we have growing populations, and we have a food crisis. So at the same time, we're growing our need for materials. So they will always stay in balance. So we're really swimming upstream in order to get a decarbonized economy, and to transition to net zero is going to be incredibly challenging unless we have very strong political leadership and the drivers in place for that. The most important starting line really is to understand what we are doing, to understand what is carbon, and what impact does carbon have in how we design and deliver buildings? And how we count carbon is through life cycle assessment. So life cycle assessment, it's a quantitative toolkit. It uses a standardized approach. And I suppose, what's the purpose of this? So the assessment helps us design buildings. It helps us make decisions about buildings. It also looks at the impacts that these buildings have in terms of their environmental impacts on carbon, on greenhouse gas, on water, and on material sources. It lets us know if our design processes are good for the climate, if they're carbon neutral, even if they're carbon positive. And this then can be fed into our design decisions at design stage or even at construction stage, where submittals are being decided. So it's a new communication tool, it's a new language for communication, but more importantly, it allows us to benchmark where we are against our peers, against good practice. And the why is always important. So why are we doing this? And it's because the construction industry is quite a dirty process. You know, we're taking raw materials out of the ground, they're going through heavy processing. It's energy intensive to do that. To change a material from an iron ore to a steel beam is intensive. To crush stone to make concrete is incredibly intensive. And so buildings and their use is incredibly intensive, as Matthew had pointed out earlier. So we're trying to understand that at a building level. And by understanding that, we can pinpoint the hotspots. So where have we opportunities to improve? And, you know, will we have buildings that are using certain materials where it will not be tolerated by the clients or the funders, that those materials will have such a devastating climate impact? So how do we target certain elements of the building in order to improve that building's impact on the environment and thereby the reputation of the client company or the investment company? And this is how, by understanding the building, by understanding what numbers we're landing on, we can get better scores in our LEED or BREEAM badging, but we can also inform decisions. So we can look at the difference between two products and pick the most environmentally sustainable one, just in the same way as we would compare two materials and look at their fire rating. We want to do the same with our materials for sustainability, and we want to see that that number has come from testing and it's credible. So, I'm going too fast here. 12 minutes in. So whole life carbon. So we talk about the whole life carbon being the cradle to grave of the building, the 50-year life of the building. And we break that down into the upstream carbon, being all of the materials that are in the building, and the downstream carbon, being the maintenance and replacement. And that's the carbon that's involved in just getting a building built and getting that building to be able to be run through its life cycle. So in the 50 years of a building, before you turn on the boilers or the chillers or the water, you've already used at least half of the carbon budget for that building. The other side of it then is the energy in use for 50 years. And you can see for some buildings this is 50%, but you go to somewhere like Denmark where they, even though they have a very green grid, their building embodied carbon is still quite low. So they can have embodied carbon that's 30% of the overall energy. But when we compare that to buildings in Ireland, it's a fraction. It's only about a third of our footprint. What's happening here is carbon is becoming a metric for investors, and they want to see that the carbon that they benchmark for their buildings in Holland, in Belgium, in Germany, they want to see that their Irish buildings are compatible with that, their UK buildings. Now, London has this in planning, so we do have to be more cognizant of where the carbon is hiding in buildings. So when we talk about this whole life cycle carbon, and we look at the embodied carbon, we're looking at the embodied carbon upstream in the process of generating those materials, bringing them to site and installing them in site. And that can be almost as significant as the energy in use during the life stage of the project, that 50 years. But we also have to consider the downstream, which is the maintenance of the building and the replacement of the building. And we have to understand at an individual material and product level what the impacts of these are. In terms of M&E, M&E is very difficult because you need to understand how many times a product has to be replaced over those 50 years. Does that air handling unit have to be replaced every 20 years? And does it have to be degassed every 5 years? And what is the fugitive escape gas that comes out of the unit when it's serviced? So it's It's a difficult process to do that. So in terms of life cycle assessment, when we look at this as a kind of a whole cradle to cradle approach, a whole circular approach, we have to understand where the materials are coming from, what our construction process is. So we have to engage our supply chain, we have to have our contractors on board. It's a whole stakeholder approach, it's a collaborative approach. We have to look at even the operation side. There's no point building a green building and then having, you know, as we had in schools, you have the janitor running the building and not understanding the management system for that. No, it can't just be built as a green building, get a LEED Platinum, and then nobody cares about it. The life cycle is important. But also, the system asks us to count what happens to the materials at the end. Do they go to landfill, or do they have a life after that? Can they be repurposed? And that's really the opportunity is, okay, we can use steel in our buildings. It's a heavily carbon-intensive product, but it can have a life after that. So when we look at whole life carbon, we've got these 20 boxes that have to be filled with information, and that each one of those would have 20 to 200 data points. So it's very difficult. We have a huge challenge in how we count carbon. And as we said, we can't do it alone. So quantification is important, and that's really where the cost aspect comes in. That's really where the metrics and come in. So when we look at a building, we're looking at the whole life of that building, but we have to break it down into its elements and systems. So we're going to report on ICMS, and we break it down. So we have our whole building in terms of its materiality. We look at the heaviest materials, which is the structure. So 40% of this building is made with concrete, your substructure, your superstructure, your secondary steel. Another 10% on top of that is your envelope, your facade, your windows, and then we have a roof. It could be a green roof, it could be quite heavy. And all of a sudden we have 65% of our building just in those 4 elements. But then we have all the other stuff that goes with that. The MEP and glass sometimes can trip you up. It can be quite carbon intensive relative to its weight. So we need to be accurate. We need to make sure that if we're giving a number for carbon, that if 2 assessors work out that carbon number, that they come up with the same figure. To date, it can be 50% out or 200% out. So just like BIM, we need to define what do we need, what information is needed and when, and what level of detail. And we have to acknowledge that at some stages of the design, the information just isn't available, and we have to use averages or approximations. But we should understand that there can't be trust, there can't be credibility, we can't benchmark if we use too much assumptions. But we also need to define our boundaries. We also need to say, are we counting the building or are we counting the site? And so the boundaries, that green line, where does that cover? Are we just covering structure and envelope, or are we covering absolutely everything, down to MEP and down to the site works? And setting goals is important. So why are we doing this after all? What is the client's objective? Is it for disclosure, or is it just to tick a box? Is it just a baseline to get to the starting line, or is it beyond that? So 2 minutes to go. So accuracy is important, and there's a huge time cost in that. And that time cost is reduced by using digital tools, by getting the team involved. And we just have to be, there are tricks of the trade in order to be able to do that. So we have standards, and just like BIM, and we can learn from BIM in this, we can streamline this process. So the idea to measure once, the idea that there's people already out there that are quantifying this, that are organizing tasks, that we can use the cost consultants and the BIM consultants. We can digitize, we can automate, and in future we can get better at doing this. We can pull information from models and digital bills of quantities. So there's a lot of standards out there, but they can be a help or a hindrance. We have our ability to use, digital models to extract information from digital models. And you can't give a presentation at a BIM conference without having a spinning 3D model, and I'm doing my best to make a balls of that. But it actually took ages for someone to put this together. So anyway, I think. So anyway, we can pull information on certain aspects of this and bring those quantities into our carbon model. So that's fairly important to do. There, I did it. I'm only a month into the new job, so you won't. Simplification isn't something that's associated with me, but as KOSMOS are a Danish company, that's what they're all about: minimalism. And so the process, the process is all about getting your inputs together, then putting that into your assessment procedure, and then generating your results, interpreting your results, and then looking at opportunities and options. And you have two outputs, right? You have your environmental impact and your cost impact. They're not different. They're one and the same thing. Cost and carbon are going to increasingly be seen as one and the same thing because there's a close correlation between them. And that's really the Danish experience, because the Danes have been doing this, for years. So it's like, Denmark or Carlsberg don't do LCA, but if they did, it would probably be the best in the world. Well, Denmark has been doing LCA, and they started in 2014 with voluntary standards. Then they brought in a toolkit. Then they brought in their draft regulations in 2018, and then they tested their benchmarks against the industry. Then they brought in voluntary benchmarks, and now they have mandatory benchmarks. Can we learn from that? Can we short-circuit it by doing that? And we can, and the Irish Green Building Council are looking at a standardised approach to this. Letty in London have done this, where you can compare your building against your neighbour, against your typology, and you can compare it here. You can see, okay, I'm starting to understand that my structural components are high. Maybe I can influence that. My in-use energy is quite high as well. I can influence that. But what's almost more important than the numbers you get is the credibility of those numbers. And learning from Denmark, we can score that. We can put a scoring system, so we can say, at this stage, moving into stage 2B detailed design, we've got really good information on structure, and we're not too bad on facade. But as we go through the elements, we're not doing so well on interiors or MEP, and we're not doing great on end of use life. But overall, for this stage of the project, we've a good score. We've 3 out of 4. And as Meatloaf would say, 3 out of 4 ain't bad. So, having a plan is what's important. Start early, get those easy wins, get everyone on board, keep the message simple. Utilize the processes that are there. We've all been using Lead and Briam for years. JV Tierney lads there know that for well. And, carbon is becoming the new metric. Just like we turned energy into BERs, and all of our clients are so familiar with BERs, we have to do the same with carbon. But we have to do it now, okay? So the takeaways are, okay, we have to understand carbon. We have to look at the toolkits that our friends from Zero have done, and work with Matthew and them to make sure that we all have a shared understanding of climate and carbon and net zero. But it has to be accurate and consistent. Our clients have to have trust that if we say that a building has an embodied carbon of 800, it has an embodied. The contractor isn't going to come around and say, you've actually given me a building that's 1,200. It's going to cost you $1 million to get this down to 900. So we have to have familiarity and trust around that. And we have to get better at digital integration. But you look around the hall here and all the tools are there. We just all need to work together and break down those silos and get connected and interoperable and work with all of our partners. Amazing the work that SEI are doing on the regulatory side. We need to work with the councils as well. But more importantly, it's within design teams. People can't really be warehousing their information. They've got to make it more open and shared. So it's really important that our project managers, our cost consultants, our client representatives, that they get on this at an early stage and get on board with that plan and drive that plan. So you need that harmonized approach that, it's not just one project in 10 is doing this as a leader. Isn't that lovely? And that goes into a brochure. Everyone's doing this together. We're all pushing together like a wave, and it becomes like health and safety. You go to site now, you don't think about not wearing goggles, a hard hat and boots. It should be like that with carbon. That data should be available without having to ask for it. And most important one is, we can learn from Denmark here. I've learned so much from them already in the last 4 weeks, and especially about interior design. But do talk to us. We're happy to collaborate. We'll all learn together. We'll all share information. So thanks for your time.